security, and policy initiatives. Well, ladies and gentlemen, this is the time now to hear from General Sabherwal, his keynote address for which we were waiting for. Before that, a bit about General Sabherwal. Ladies and gentlemen, General Rajeev Sabherwal has held multiple key assignments in Indian Army, including DDG Military Operations, Chief Signal Officer, ADG Tactical Communications, Chancellor and Commandant of Military College of Telecom Engineering, and Signal Officer in Chief. Post-superannuation, he was appointed as Government Director on board of Indian Telephone Industries. With 4 decades of huge accomplishments, he has come to be an expert of ICT, information technology, cybersecurity, and AI. Well, over to you, General Sabherwal.
Good morning to each and everyone who is attending this particular seminar today. And my heartfelt gratitude to SAPI, specifically to Mr. Alok, Dr. Goyal, Sarang, and everyone else who has introduced this particular topic and made my task a bit easier. Seeing the subject proper, I will not dwell into too much of technology because what I can see from the attendees, there are people from general walk of life. Neither I will try and become too operational because there are people who are non-military also. So my presentation is going to be a combination of a bit of technology, but it is more going to be how technology is being applied through an operational end. And towards that, I would like to say that in the era gone by, warfare used to dictate the kind of technology which will get unfolded. If you see the events of World War I, World War II, and even any event after Industrial Revolution, you'll realize technology developed to meet the requirements of the military. You take the nuclear bomb, you take submarine, you take radars, you take microwaves, you take tanks, you take any such technology. However, today the paradigm has changed. With the dawn of information age, today you find technology driving warfare. And one of the most important or key technology which is going to drive the warfare of the future is going to be 5G. And how is it going to happen, etc., I will cover in my particular talk. So I've got a small presentation laid out. I will take the assistance of my slides just to assist you all in better understanding of this particular topic. Okay, are my slides visible?
Yes, sir. Yes.
Okay.
Perfectly visible.
Okay. So let me start by trying to give you a kind of evolution of warfare as to from where the warfare started, where is it today, what were the communication requirements of the era gone by in the previous era of warfare, and what is the communication requirement today. And if we understand this, then we will be able to place exactly what kind of requirements is 5G going to meet for defense. And then we will build upon the use cases of defense, which 5G is going to fulfill. So before the industrial age warfare, revolution started in UK and Europe, we used to have something called agrarian age warfare. I will not discuss agrarian age warfare, which was basically on chariots and spears and everything else. Let's jump straight to industrial age warfare. And in the 19th century, once Faraday's laws came up, once the telegraph came up, once Marconi came up with his radio and patented it, and J.C. Bose came out with his theories, etc., the whole paradigm of communications changed. And in the industrial age, there were certain characteristics of communication requirements which were meant for industrial age warfare. And to a large extent, right from World War I to up till the Gulf Wars, we see industrial age warfare taking place. To a large extent, Indian Army, Indian Armed Forces still fight in the industrial age structures. And the kind of warfare which was fought in industrial age was something called platform-centric warfare. And the typical characteristics of industrial age warfare were that we used to find platform-centric warfare, which is nothing but where the sensors, shooters, and decision makers are tightly coupled to each other. So a ship, a tank, an aircraft is one where all the sensors, shooters, and decision makers reside into one, where they do not share. And in this kind of warfare, the communications are always linear, they are always hierarchical. So they flow from the army quarters to the commands, commands to corps, corps to division, division to brigade, and it's typically hierarchical in nature, very linear in nature. All activities which take place are synchronous in time and space. So therefore, if you want to know something what's happening in the battle, what's happening in the operational area, you have to go to the operations room where all the communications or the sensors information is coming, where shooters are there or their information is there, and the decision makers take the particular decision from the ops room. A typical example of what is synchronous in time and space would be that today the seminar started at 11:30. You had to be logged in at 11:30 to be hearing this particular seminar live. And this is what is called synchronous in time. But if I had stored this in, say, YouTube, and you could listen to this seminar anytime of your spare time, this is asynchronous in time. And the moment I store it in YouTube and pick it up on my laptop or my desktop or my mobile or anything, I become asynchronous in space. Another characteristic of industrial age warfare was that all the entities were dumb. When I say entity, any sensor, any shooter, any decision maker is called an entity. Any object, any tank, any aircraft, everything is an entity. When I say dumb entity means this particular entity cannot send or receive data. So obviously there was lack of situational awareness. There was lack of common operating picture in this kind of warfare. Now, somewhere around 80s, we saw a marriage of communication and computing taking place. So we find the radio sets, which were meant only for communicating, started getting computing element built into it. A typical example is your smartphone, is your iPads, and so many other things. And similarly, the computers also started getting communicating elements built into it. The cellular phones which Mr. Alok spoke of, the 1G, etc., or 2G, did not have a chip built into it, or a rather computing element built into it. But the moment we came to 3G phones, we saw a marriage of computing and communicating take place in the same device. Once that took place, every entity or device or equipment could send or receive data. The moment you can send or receive data, you're called a smart entity. So in today's warfare, the communication requirements are that every entity, whether it's a soldier, a device, an equipment, a weapon system, an aircraft, or ship, or whatever, should be a smart entity. It should be able to send and receive data. Your smart watches, your smart TVs, etc., are all smart. Next requirement is that all entities should be networked. They should not be linear or hierarchical. They should be a part of network so that they can share the information with each other. And of course, they should be asynchronous in time and space. So your mobile phone is a perfect example. All of you can see your Hotmail or Gmail or any particular mail which you have anytime and anywhere. This is asynchronous in time and space. Once this happens, you get shared situational awareness. You know everything else, what the other people are knowing. You get a common operating picture of the particular phase of battle or the stage of battle which you want to do. And once this happens, every entity can take their own decisions. They become a kind of what is called self-synchronized. And the linear and hierarchical nature of decision making or the flow of hierarchy breaks. And the summary of this information age warfare is that the sensors become independent of services. They lose their chains of Army, Navy, Air Force. They could be anywhere. Shooters become independent of platforms, whether they are on sea or land or air. And decision makers become independent of geographical locations. They could be anywhere to take a particular decisions. Now, if these are the characteristics of information age warfare, and you will see, and as we go by, that 5G tends to fulfill all these particular requirements. Now, this particular diagram was covered by Mr. Alok. Now, here broadly, I would like to say that 5G primarily works in 3 domains. EMBB, which is enhanced mobile broadband, MMTC, which is massive machine type communications, and URLLC, which is ultra reliable, low latency communications. Now, the characteristics of all these three are little divergent to each other. However, the complete manifestations of the requirements of the defense in the typical battlefield are met by at least one of them. Now, what has been rolled out right now in front of you, we could roll out 5G as a standalone, where the backend, the core network, as well as the access network are all based on 5G. Or we could have a non-standalone 5G, where the backend or the core network is still 4G LTE, and based on that, just the front end experience or the RAN experience is of 5G. This is a non-standalone kind of a rollout. Typically, all over the world today, including people like Airtel, etc., you will find non-standalone 5G being rolled out. And in this kind of the present releases of 3GPP based on 5G, what has been released, we are basically getting something called EMBB, which is enhanced mobile broadband, which is a better version or a more enhanced version of 4G what we are getting, where data rates are very high. It could go right from 1 Gbps to up to 20 Gbps. Latency has come down, and all the whole experience of this is much better than what it used to be. The data rates have gone up, capacities have gone up, spectrum efficiency has gone up. But there are a few more things which Mr. Alok spoke of. For example, massive machine type communication. In case we want to roll out Internet of Things, and in military, this is called Internet of Military Things or Internet of Battlefield Things, then we need MMTC. This is only possible in a particular thing where in certain release of thing, where millions of devices will be able to connect. There will be a battery conservation. The energy requirements will be very low. Of course, the data rates will also come down drastically in this particular thing. And the third one, which is ultra reliable, low level communications, is meant purely where mission critical requirements are there. For example, if a missile is launched and you want to intercept this particular missile, you will have to be in UR LLC to take care of that particular missile. So we will keep these three verticals or these three characteristics of 5G in view and move ahead. Now, apart from the three domains which I spoke of, there are few more key technology drivers of 5G. It's important to get a glimpse of these key technology drivers also to get a better understanding of how exactly the various use cases of defense will take place. Like the first one is heterogeneous networks, or which is also called HETNet. Now, 5G has got the capability of interconnecting various kinds of networks under one. So you may have a backend or a core network which works on a macro cell layer, which is a bigger radio, but it could connect certain small cells, which could be pico, which could be femto, which could be micro. It could connect LTE, it could connect Wi-Fi, it could connect wired connectivity, it could connect HSPA. So all kinds of different networks can be connected onto one single 5G network, which has got a common core, but the access is multifarious. It is different. And once I come to the defense application, you'll realize how this lends itself to what kind of operations. Okay, these are very important characteristics of 5G. The second one is MIMO, which is also called massive multiple input, multiple output. In plain simple terms, we used to have one antenna which used to transmit and one antenna which used to receive. In today's 5G world, or even in 4G, we saw once the MIMO was introduced, that one particular antenna, we have got an array of antennas built up in transmitter and an array of antennas also in receive. So both sender and receiver today have multiple arrays of antenna, which could be 4x4, 8x8, 64x64, 256x256. When I say array, means there are 64 by 64 antennas at the transmit and as well as in the receive side. Now, this leads to a lot of spatial multiplexings, number of users working on the same time frequency resources. And therefore, there is a huge improvements in the throughput, huge improvements in energy efficiency, huge improvements in the spectrum saving, etc., which takes place because of MIMO. Okay. In this, there are certain other things like beam forming, null forming, and all that, which I'll not go into because it will become a little more technical. The third characteristic which I want to talk of 5G is millimetric waves. Now, if you know the spectrum, most of you must have heard what is HF, VHF, UHF, SHF, etc., etc., and move up in the higher ranges of spectrum, specifically from say about 25 gigahertz, 24.25 gigahertz. When you go up to 100 gigahertz and go up to even up to 300 gigahertz, the kind of wavelengths which are there are called millimetric waves. Now, the URLLC, which I mentioned, high reliability and low latency communication, works primarily on millimetric waves. So there, as we go up, there is a huge bandwidth which is available for our usage. However, the attenuation is very, very high. The range is reduced drastically. So there is a trade-off between what you want operationally and what you're ready to sacrifice. So in millimetric wave, wherever there are mission critical things where latency required is less than 1 millisecond, and very, very reliable things, for example, carrying out remote surgery, any remote operations, AR, VR, which Mr. Sanang spoke of, all this would require millimetric waves. Next characteristic is D2D, which is device to device communications. In today's typical till up to say LTE or 4G, you talk to a BTS, BTS talks to you. So all communications is from through or via BTS. We used to have D2D in another technology called Tetra. Some of you may have heard of this Tetra technology, which used to permit D2D communications. LTE, later versions of LTE, I think it's beyond 16 or 17, I'm not sure which number. Some release of LTE permits D2D communications. But 5G, I think after release 15 or 16 is permitting device to device communication where you do not require the G node B or something to take place and two devices can talk directly to each other. Next, I want to talk of something called software-defined network. These days, everything is becoming software-defined. There are software-defined radios, software-defined exchanges, software-defined routers, software-defined switches. 5G also has software-defined network. Primarily in this, what happens? The network plane is decoupled from the data plane. And therefore, things like programming, there is a central controller which helps you in intelligence. You can use software and do number of things. On the same physical platform, you can derive certain software functions where you don't have to put the physical devices. They can be realized through software means through that particular controller only. Next is something called network function virtualization and network slicing, which is nothing but a corollary of software-defined network itself. Okay. In this, most of the functions of the network are realized in software and they are independent of the underlying server hardware. So basically, a virtualized nature of things or network functions can take place. And due to this, something called network slicing is possible. And network slicing is nothing but what it refers to is a division of the physical network into multiple virtual networks that are unique and optimized for a particular service or a particular application. For example, one of the slice of a 5G network could work on EMBB, one slice could work on MMTC, one slice could work on URLLC. Or one slice could still continue working on 4G LTE, one slice could work on, say, 5G, one slice could work on Wi-Fi. So you could have any kind of slicing based on your user requirements, which is possible due to the software functions or network function virtualization and software-defined networks in 5G. Another key technology driver which is available, which is supported by 5G, is something called MEC or multi-access edge computing. This is nothing but the cloud services are today now available at the edge. It could be tactical edge where the battle takes place, or on the edge of any corporate or anywhere, where local computing is possible by the device. So local computing takes place, there is some kind of decision making which could take place, and the edge cloud then gets connected to the main cloud, and this kind of thing is supported through 5G. Now, if this is clear to you, there are certain use case analysis of 5G. Now, what I have done is I've taken the three domains of MMTC, AMBB, and URLLC, and given various functions which are supported by each one of them. So we could discuss each use case here itself, but you'll find a lot of overlaps in this. So this is just to show you that, okay, each domain has got specific use case of defense, which is met by this particular domain. Another way to deal with the defense use cases in defense is go Army, Navy, and Air Force way. But again, you will find smart bases, for example, would be in Army also, smart cantonments. It will be Navy also, smart naval bases, smart Air Force bases. So again, these use cases are very, very common. So what I have done is, I have taken all major use cases of 5G in defense. And of course, only your imagination is the limit of where all 5G can be used in defense. It can be used in anywhere, wherever your imagination goes to. So these are the major use cases. I will just take them one by one and use the same technological drivers, functional drivers, and domains which I had spoken earlier, and try and tell you how this fits into all the use cases of the defense. Today's warfare, as it's not like what we fought in 64, 62, or 71, or wherever. Today's warfare is all multi-domain and multi-dimension. When I say multi-domain, that means land, air, sea, space, cyber, electromagnetic. War is fought in all these domains simultaneously. When I say multi-dimension, it could be at any level. You could be fighting at, say, psychological warfare, or you could be finding legal warfare. You could be finding doing perception management. So various dimensions of operations are also there. Now 5G, since it supports heterogeneous networks, you could be fighting in any dimension or any domain. All the heterogeneous networks can be connected on one single core network of 5G. Plus, 5G also has one unified network management system, which manages all the networks, whether you're fighting in the naval battle or the air battle or the land battle or cyber or whatever it is. It is all possible due to NFV, which was network function virtualization, software defined networks, and network slicing. So this is how you understand that all these technologies lend themselves to a modern battlefield today, which is multi-domain and multi-dimension in nature. Another very important defense requirement is ISR, which is nothing but intelligence, surveillance, and reconnaissance. And different synonyms are used for that. It could be called TAC-C3I, which is nothing but tactical command, control, communication, intelligence. C4I2SR. We have Jal Matharu here, who was DGIS, who is the authority on these kind of things. Now, what happens in a normal modern battlefield today is that we have hundreds, thousands, millions of sensors. You could have electro-optical sensors. You could have sensors in the skies, sensors in UAVs, drones, sensors on LLTV, your day cameras, night cameras. So all these sensors have continuously are generating their output. They're sending this sensor data to the shooters, to the decision makers, for them to collate, relate, analyze, and take out some information from data and some intelligence from information. Okay. For this, you need some kind of technology which can churn this particular data, aggregate this data, and make some sense of this particular data. 5G lends in all these things. MMTC supports connectivity of millions of devices in a particular square kilometers. You may have as many as 1 million devices in a particular square kilometers through MMTC, where the battery life of an IoT device could be anything from 5 to 10 years. So very low power requirements, huge connectivity possible. Of course, data rates are a little lower, but where data rates requirement is high, you could use eMBP. So this is nothing but a multi-sensor data requirements are being fulfilled in near real time through 5G. Now, once the decision makers get so much of information, they know where are the red forces, where are the blue forces. We say that the command and control functions of all the commanders at large would also get enhanced. They'll be able to pass data much faster, latency will be down at much faster rates. There'll be videos, there'll be live connectivity, everything, which is nothing but an enhanced mobile broadband for your command and control. IoT, Internet of Military Things, Internet of Battlefield Things is possible through massive machine type communication, which I've already spoken of. Now coming to forward edge operations. Today, battle may be fought at the tactical end, but it may have strategic implications. Why? Because all entities who are fighting in forward edge are also connected at any point of time. So anything happens in Galwan, anything happens in Doklam has many, its implications are at the national and international level. But these were forward edge operations. And your requirement is to connect these operations so you could get live what exactly is happening. You have the situational awareness. You have a common operating picture. All the entities which are fighting there should be self-synchronized. Now, all these requirements are met through multi-axis edge controller of 5G and massive machine type communications of 5G. And whatever data is computed here is further connected to the main cloud, which is connected to your command headquarters, army headquarters, and everywhere else for a situational awareness to a higher headquarters also. Now, all of you have heard of swarm drones, killer drones. You're seeing movies, and you're seeing various examples where, in Russia-Ukraine war, swarm drones were used. In bombing of the Aramco oil fields in Saudi Arabia, they were used. Azerbaijan, Armenia warfare, the drones were used. Here, you require very, very reliable connectivity and very low latency. And therefore, your requirement of one domain of 5G, which is URLLC, is required over here. Okay, so this is fulfilled through URLLC. Let's come to smart bases. You can have smart cantonments, you can have smart naval bases, smart air force bases. All these are possible again through ultra reliable low level connectivity, which works on millimetry waves. Okay, because everything has to operate in real time in a smart base. It has to give you the perimeter defense, the QRTs, everything else which takes place in a smart. There's a huge connectivity of everyone. Coming to battlefield networks, which is the job of what the Corps of Signals does in Indian Army, you require better data rates, you require low latency, you require better connectivities. All this is done through EMBB of 5G. Now, today's battle, most of you are wearing, I'm sure, must be wearing a smartwatch, whether it's of Apple or if it's of Fitbit or whatever it is. Similarly, today's soldiers also wear battlefield wearables. It could be exoskeleton suits, it could be watches, it could be helmets, it could be all the wearables are like a single device which has to be connected to each other. And today's soldier is also a connected soldier whose whole thing is like, you must have seen in a lot of SF special forces movies or Rambo movies and all that. You must have seen what all soldier is connected, what all devices he's got. He can actually transmit anything from anywhere to anywhere. So battlefield wearables are also possible, and this is a perfect use case for defense of 5G. AR/VR, Mr. San has already spoken. We utilize AR/VRs or would be utilizing it in all the simulation exercises, all our training institutes for carrying out various war rehearsals, IFF, as well as various tracking, target acquisition and tracking. So basically technology which will be used would be EMBB. Some of you may have heard of hypersonic weapons. Now, hypersonic weapons are the ones whose speed is more than 5 Mach, which is, they can work at 10 Mach, 10 times the speed of sound, 20 times, 50 times, etc., etc. At those speeds, guiding of a hypersonic weapon becomes very, very critical. So basically, these weapons, after re-entering into the atmosphere, are basically gliding at very, very high speed of more than 5 times the speed of sound. And therefore, the onboard sensors and onboard data which is being churned out is so high, the latency requirements are so low that this is possible only through 5G. Now, this was guidance of hypersonic. Imagine if a hypersonic missile is coming towards India and we need to intercept this particular missile. Our reaction of identification, detection, as well as launching another interception missile has to be less than 1 minute. Now, this is possible only if you have a 5G connectivity where latencies would be very, very low. This is possible through URLLC of 5G. Mr. Alok also covered autonomous vehicles. So I'm also covering autonomous vehicles that when I say autonomous vehicles, it could mean a ship, it could mean an aircraft, it could mean a tank, it could mean a mine clearing vehicle, it could mean anything in any robot which has gone in a bunker, in a terrorist hideout, or anywhere. Now they need to be guided, they need to be controlled, command and control needs to be sent to them. They will have certain data which is on board and certain data which is off board. Now, both these things need to talk to each other. And that is how you will be able to control this particular autonomous vehicle. This again requires very, very reliable, mission critical kind of reliability of communications and very low latency of communications. This again is possible through 5G. Of course, some things like logistics, maintenance, I need not even dwell upon. This is understood that this will be taking place very, very efficiently through 5G. Another major area which I want to cover is healthcare. 5G, even 4G lent itself to healthcare, but 5G would lend very, very well. Things like telemedicine or telehealth, remote patient monitoring, remote surgery, connected ambulances are all possible and very efficiently done through 5G. A buzzword is anything remotely managed, whether sensors are being managed, drones are being managed, maintenance being done, surgery is being done, repair and recovery is being done. Anything where remote managing is required requires very reliable communications. You require very low latency communication, require high data rates, you require huge number of devices to be connected. All this is possible through 5G. And therefore, what I said earlier also, I want to sum up once again by saying that only your imagination is the limit in defense where 5G cannot be applied. It can be applied anywhere. A word about the spectrum which 5G utilizes. Today, 5G is available in low band, and auction has already taken place in India, in mid band, specifically from 3.3 to 3.6 gigahertz, the auction took place. So the sub 6 gigahertz is presently the one where the entire world is focusing the 5G on. Right now, millimetric wave and 5G between 24 and 100 gigahertz has not yet been launched in India and most of the other places too. Very, very few places in the world it has been launched. But in the times to come, you will find this happening. Your URLLC is possible only in high band or millimetric waves, whereas EMBB and MMTC is possible in sub 6 gigahertz band also. As far as India is concerned or the Indian armed forces are concerned, these are the various 5G bands which are prevalent in India, and every country has different 5G bands. So what the ITU allotted 5G bands for India are these. The primary focus where people are working now, specifically Reliance, Jio, Airtel, etc., is N28 and N78. The armed forces also have certain allocation in these bands. I will not dwell into how much and where, etc., because it's slightly classified in nature. But suffice to say, Indian armed forces have got the options of utilizing the spectrum which has been given to them by way of an MOU between the Ministry of Defense and Ministry of Communication and IT, or they could also piggyback or leverage the spectrum which is there with the telecom service providers and utilize their networks with a particular slice which has been meant solely for either Army or Navy or Air Force, all the three services combined. So both the options are possible. We could do network slicing for our specific requirements, or we could go in for a dedicated network which is only there for the three services, or Army, Navy, Air Force could go separately, or in a joint kind of a scenario, each theater could have one, or pan-India, all the three armed forces could have. Various options are there. These are being discussed at policy level in the armed forces, and soon we shall come to know about these. What are the current challenges which we face, for 5G right now? It could be both technical and operational. For example, today there is a requirement of huge foundational digital infrastructure, including various communication nodes and power requirements in the border areas. Most of you are aware of Siachen, Leh Ladakh, Northeast, or Tawang area and Arunachal area and all that. These are very, very difficult areas where communication requirements are extremely critical. But there is a scarcity of power and nodes, etc. requirement. So this digital infrastructure will have to be built in case you want 5G there. Now, since the number of devices which get connected in 5G is, like million kind of devices in 1 square kilometer, that increases the security threat as far as and the surface area for attacks and threats of various kinds. So there is something called CIMA, cyber and electromagnetic activities. CIMA consists of cyber warfare, electronic warfare, ELINT, electromagnetic spectrum operations, and all these kind of operations combined are called CIMA activities. So in the operational areas, we may be subject to enemy CIMA in case 5G is deployed over there, because the surface area has gone up, number of devices are connected on 5G, and most of the edge devices are also working on 5G. Next challenge is lower range of communications. As we move into millimetric waves, you will realize the range drastically reduces and the data rates go up drastically. But as we come down to say 700 megahertz spectrum, the ranges increase, but the data capacities goes down. So both work inversely proportional to each other. So if you require huge data, the ranges will have to be very small. In fact, they can work only about 100, 200 odd meters. That's all. 5G frequency bands do not, specifically millimetric waves, do not penetrate very well in rain, foliage, fog, etc., etc. And that's why they are typically meant for smart bases, meant for buildings, meant for warehouses, ammunition depots, etc., etc., etc. However, other frequency bands which are there of sub 6 gigahertz work very well in these particular things. Now, another challenge which I spoke of, allocation allotment of spectrum, which I covered in my previous slide, is a challenge, but we have certain share of spectrum, the defense forces, which we should be able to take care of this. The next challenge which I spoke of is MIMO and designing of the antenna, which are very small, very ruggedized, which could be packaged for military needs. Now, designing of such antennas, which could be transportable, which could be mobile, which could be man-packable, or these things would be a challenge. The 4G came out with something called a NIB, network in a box. I'm sure 5G would also come out with something similar, and the defense requirements would be met. The last challenge is 5G is not a technology which is in isolation. 5G has to be seen in conjunction with artificial intelligence, robotics, big data analytics, drones, AR, VR, IoT, and blockchain, and every other kind of technology. It's a combination or amalgam of all technologies which actually give you the kind of operational dividends which you're looking for. Now, unless in IoT, for example, in IoT, if AI and 5G do not work combined, you will not get that dividend which you're looking for. And similarly, let's take an industrial or anywhere else, the 5G has to work with robotics. Similarly, in MEC, if the edge cloud is connected to the main cloud and the commanders have to be fed and analyzed or fused kind of sensor fused kind of a data, the big data analytics has to take place. AI has to take place. Machine language has to take place, and so many other kind of technology. So the defense forces will have to go not only for 5G, but all the other technological advancements will have to be, inducted as a bouquet kind of thing. So let me leave you with what is the future of 5G as we see it in India today, and maybe to most of the other parts of the world also. Starting from 2023 and going into the future of say up to 2028, somewhere till 6G comes up, you will certainly find a huge adoption of 5G from 2023 onwards. Yesterday itself, I was reading in the papers that Reliance Jio has already got fielded in, I think, 120 odd or more than 120 cities in India. And in the times to come, you will find this growing into the villages, tier 2 towns, tier 3 towns, and everything will be covered with 5G. As of now, the rollouts which are taking place are NSA 5G rollouts, which I covered earlier, that they have the 4G or LTE core, and only the access part is 5G. But in the future, you will find standalone 5G rollouts taking place. In fact, Reliance Jio has already said that all our rollouts would be standalone 5G. Whereas the other two players have said right now they are on NSA mode. See the growth of 5G. From 23 to 28 in next 5 years, you're going to find 5G market growing at 17% CAGR, which is a huge jump. Right now, we see macro cells servicing most of the areas. Small cells, picocell, femtocell, etc. have not yet come up because millimetry waves have not yet come up. And total research and fielding of that has not yet taken place. In the times to come, from 23 onward, you'll find mushrooming of small cells taking place. Most of the 5G network which have come today is proprietary in nature. Therefore, the core network and the access network or the RAN as such were proprietary to a particular technology, proprietary to a particular vendor, etc., etc. And therefore, 3G PP, which is the standardized or the policy making authority on cellular networks, 3GPP, they came out with a particular version called Open RAN. Therefore, you may have a core, but any company can give you the radio access network, which is, open. And you could fit in of any vendor of any country or any kind of a technology here. Another future of 5G is fielding of private 5G networks. So apart from the 3 TSPs in India, you find that Adani has already taken some spectrum for his private Adani network of 5G. And tomorrow, Army, Navy, Air Force, and any other organization can also have their private 5G networks. The defense forces already have their private networks, which are working in 2G, 3G, and based on CDMA and WCDMA. So we already have an experience of running our own networks for our own operational requirements. So in the times to come, we may also go in for our private 5G networks, which have got nothing to do with the civilian world. Another feature which I want to highlight is the 5G in the times to come is going to be integrated with, say, metaverse, Wi-Fi 7, IoT, artificial intelligence, machine learning, cloud computing, data analytics, blockchain, etc., etc. With each passing day, 5G's integration with other technologies will continue to increase. Right now, 3GPP is on the release 17. With each release, you find new features, new technologies being added to 5G. So with the dishing out of release 17, the basic technology of 5G is currently has been standardized, has been rolled out to various vendors and countries. From release 18 onwards, we will find advanced 5G releases taking place. So right now, work is going on release 18, release 19. In the times to come, these will be released. For example, release 17 supported satellite communications on 5G. Release 16 supported some other technology on 5G. So as we go by various releases, various technologies get inducted into 5G also, and they continue to meet some requirements of the defense. And 6G will continue to be the subject of research and experimentation in 2023, but it will also look for mainstream adoption in the next 5 years. So maybe by about, say, 2028 to say about 2030, we will find more and more of 6G, where it will be nothing but today, instead of 5G, what we say till 4G, it was basically human-to-human communication. But with 5G coming in, we have connected virtually everyone and everything together. That means human to human, human to machines, human to objects, human to devices, human to equipment, and between machine to machine, device to device, equipment to equipment, and etc. everything. But it was only communications. In 6G, you'll find AI being part of each and every kind of our narrative would be based on AI in cellular communications also. And of course, it will work in terahertz kind of communication, anything from 1 terahertz to say 3 terahertz or something like that, it will go up to. So the last line, what I want to leave is that the most important 5G applications will be implemented not in the civilian world, but in the military arena. Thank you so much for your patient listening. And I'm open to question answered by any one of you.
Thank you, sir. Thank you, General Sabherwal. In fact, I am still, feeling like we landed upon mine of information. And that was so in depth, so engrossing. In fact, left us craving for more. I'm sure all of us would agree to that. Besides also wondering whether in near future, these wars can be fought with the help of robots and precious lives of our Jawans being saved. Well, with this wish in my heart, may I, before I leave the floor open for question and answers, acknowledge presence of our two very senior members of participant. One, Major General Ashok Kumar. Sir, a very hearty welcome. Another Vice Chancellor of University of Engineering and Management, Sir Viswajay Chatterjee. Very warm welcome, sir. And thank you for your kind presence and support. Well, ladies and gentlemen, time for question answer sessions. So as I requested earlier, you could shoot these questions to my inbox, and then depending on who it is addressed to, will be taken by our speakers. Sir, here is one question. This stems from your challenges wala slide. You briefly touched upon that there could be, little dark side of this technology also. So it's based on this. This gentleman asked that dependence on 5G means that being more connected, more automated, and deployment of AI-based system to reduce manual surveillance at borders. But isn't it going to add up to increased security attacks and increased efficiency and efficacy for cyber criminals, or even our enemy too? Just remembering the recent hacking which took place in All India Institute of Medical Sciences. So Sabherwal sir, if you could shed your thoughts.
Yeah, thank you so much. Whoever has asked this particular question is absolutely right. The moment you have so many hundreds of connected devices to each other, but the attack surface area goes up, and you are vulnerable to what I spoke of, SEMA attacks, which could be anything, whether it is cyber or it's electronic warfare attack, but it will be through electromagnetic spectrum only, because you are on a wireless kind of a connectivity. Okay, so therefore we will have to see our adversary's strength of how capable, what kind of EW strength does he have against you. Now the point to be understood is that the ranges of IoT devices are extremely small. You see your Wi-Fi range in your house, it ranges, or your Bluetooth ranges, etc. They range from few feet to maximum 100 feet, 200 feet, etc. So millimetric waves do not go beyond 100, 200 meters. And therefore, I would say if you're connected on your LLC or something, you're working on millimetric wave bands, this thing is pretty secure. But if you're on a lower frequencies of 700, 800, 900, 1300, 1800, 2000, etc., where the ranges is high of the communication, then yes, you're subjected. You could be subjected. But 5G inherently has also got a lot of, safeguards made into this. It's a kind of, I won't say CDMA based, it's a OFDM based, but a kind of safeguards are there to take care of it. But yes, his question is right. You have to guard against it. You have to take care of it. Yeah.
Thank you. There is Gunjit ji who is asked this question, sir.
Shall I add on?
Gunjit ji, you would like to speak?
Okay.
Gunjit ji, or may I speak on your behalf? Okay, sir. So I'm here.
Sorry, sir, Alok wants to add.
Okay. Mr. Alok,
Sorry,
yeah.
I just wanted to add something on this, 5G vulnerability, the question on that. With the 5G, since the, high speed bandwidth and low latency and the more reliable, there will be also the cyber security based on the AI is also being added, where right now we can see that, majority of the, identity management done with the face recognition, but we can get into the voice spectrogram and some other features when the public network we talk about. And then definitely the private network generals are already, added that is going to be much more additional feature and safe. So this just to add on to that.
Thank you, Alok ji. Here is another question. This is for General Sabherwal, please. From Mr. Gunjit ji. in the next 3 to 5 years, what is the most plausible application of 5G with other technologies that you see being made operational? General Sabherwal.
Yeah. As per me, a combination of 5G with AI would be the most common, rollout of things, because if IoT has to come up, if so many other applications have to come up, then AI, a combination of AI and 5G would be the most plausible one in the next 3 to 5 years. On the technology curve, 5G has moved ahead and it is moving towards maturity stage. Okay, as I said, with the release 18 onwards, on a technology curve, which most of you must be knowing, we are now at the ascendancy level of 5G. 4G is on the decline, or rather right on top, and 3G is already have declined. If we are there, the AI is also pretty mature technology today. So combination of these two, I think, would be the, and all the use cases would be based on these two kind of technology in next 3 to 5 years.
Thank you, sir. Thank you. This seems to be last question. The ban on certain foreign telecom OEMs, upon which most of the 5G technology development depends, seems a hurdle in quick adoption of 5G as of now. Your comments, please.
Yeah, you see what happened once when 1G came, 2G came. See, every decade we have had one generation of cellular technology unfolding in India. In the 80s, early 80s, we started with the 90s brought in 2G, 2000 brought in 3G, 2010 brought in 4G, and around 2020 we got the 5G. India missed out on the previous 4 generations of this thing. Why? We did not have a Make in India solution. We did not have a stack which catered for these technologies. But with 5G, the similar thing happened. Other people like China, Sweden, Norway, etc., US, etc., had Korea, they had taken the lead, and most of the 5G technology, the patents were with these particular things. Till India woke up and said, no, we will have a Make in India stack now. And therefore, various startups, there were government incentives, various companies, various startups, various industries which came up. And today, I'm happy to say that I personally do visit some of these startups in Bangalore and Chennai and all these things. And I've seen them working, making the complete 5G stack from macro to small cells. In fact, in the last IMC, a 88-hour radio was inaugurated through HFCL or something. And there are so many other companies which are coming out. But with 6G, I can assure you that the complete technology right from beginning, we will have our Make in India solutions only. So therefore, to get this thing going, the government had to ban starting from China and other companies also. So Chinese companies were banned by US, by UK, and so many other things because of secrecy related issues. So I'll not go into that. Most of you know about it. But other companies which were non-Chinese in nature were permitted to give their equipment. And most of the equipment which is there in India today is non-Chinese in nature. Till 4G, we had Chinese equipment also. But with 5G coming in, there is no Chinese equipment. It's all non-Chinese equipment. But from 5G, you will find a Make in India stack being rolled out. Starting from, say, Jan 24 onward, you'll find the moment ORAN solutions start getting fielded, you will find Make in India solution stacks being rolled out.
Thank you, sir. It appears that time to conclude. Pradeep, any last thoughts on behalf of SAPI?
I'll just, in the end, conclude what General Saab has very nicely elaborated the defense side of it, and of course the Alok and Sarang have given the glimpse of their introduction to the 5G technology as well as to the meta applications. The very well, General Saab has explained about the 3 domains and the key drivers of the 5G technology, because my purpose of choosing this topic was to explain it very simple terms. And what Sir has explained is the simplest of the terms of the 5G today. You will find a lot of technical jargon. He has brought it to the common man's language, how the battlefield, how the tactical operations, how the tactical communication, how these things will be used. So 5G is basically game changer for several of the functions of the armed forces. I'll not go into details of it, but his narration of the major use cases has just given us a glimpse into the areas where we can just imagine, and what he has told, the sky is the limit. So now from today onwards, all the viewers and others will be putting up YouTube also. They can think of YouTube. It is very good food for thought for the startups, for the young technical persons, not even them, otherwise also to come up and with the solutions for the issues and problems what we face. It will certainly lead to better connectivity and a force multiplier in our functioning of day-to-day life, as well as the operational. What he has told about the future of 5G, it's very, very bright. And for next few years, we'll see explosive growth in the data rate also, as well as the he has told that CAGR will be 17%. So certainly it will give big boost to the economy. And the good point of the 5G is that private 5G networks over and above the common service providers network, that is also a very good technology of this particular ability of this technology. So with this, I'll not take much time. It's already 80-90 minutes now. I end by this conclusion, and in the end, I'll request General Saab, General Matharu or General Ashok Kumar also to, if they have something to tell, we are happy to give you this stage.
Thank you, Pradeep. Thank you. Sir, General Sabherwal, sir, a very big thank you for taking all the pains and giving us your precious time. Sir, you talked, in fact, your talk was loaded with your futuristic insights, and which were quite balanced with your tons of experience which you have. And sir, left wondering whether we could listen to you once again, maybe on the future of warfare, because you talked of wars being fought in psychological domains. My God, sir, scary indeed. Thanks, Alok-ji. Thanks, Arang-ji.
May I say a few words since
Sure,
I'm
sir.
General Matharu here?
Sir, most welcome.
Yeah. First and foremost, I would like to thank Mr. Pradeep Gupta for inviting me to be a part of this absolutely amazing webinar. And it is such a pleasure to see my old colleague, General Sabherwal, talking here. He is so full of knowledge, and I just wish him well, and also wish Mr. Gupta well in taking our country forward in this very important technology, because it will give us the edge which we need for challenging future which we are entering now. Once again, thanks for having me as a participant, and wish you all the very best, everybody, and Jai Hind.
Thank you, sir. Jai Hind. And your presence here is our blessing, actually. I also acknowledge presence of Major General Ashok Kumar, Professor Chatterjee, and everybody else. My apologies if I'm not naming anybody individually, but then it's your love and your support which encourages and motivates SAPI to persist, to persevere in its small pursuit of big knowledge. Thanks from the bottom of our heart. Have a great day. Have a great weekend. Thank you very much, one and all. Thank you so much.